So this is the quiz for chapter 4, and on the first question it says, the students in the biology class kept a record of the height of plants for the class experiment. So this right here is the data that the problem gives you. And the first part tells you to sketch a histogram. So first, we have to note that 32 is the minimum, and then 75 is the maximum, just so you know where it ranges from and how to make your histogram. Okay, so first we should label all the axes. So title is histogram of plant heights. And so we're recording that data right there in the height, so it's going to be the plant height. In centimeters. And then right here is going to be the frequency. Since your smallest value is 32, we can start at 30 and do it in multiples of 5. So between 30 and 35, there's only one value, which is 32. So, oh, hold on, let me label the frequency. Okay. So there is one, and between 35 and 40, there's also, no, hold on, there's 2. So, okay. Between 40 and 45, there's 3. So, we put 3. Between 45 and 50, there are 4. Between 50 and 55, there are 3. 55 and 60, there are 2. Between 65 and 70, there's 1. Okay. And between 70 and 75, we don't have one. So there's one between 75 and 80, so there's going to be a gap in between. And that one is also 1. Okay. So B says, find the mean and standard deviation of the plant heights. So we're going to put in our data values on the calculator.
All right.
Okay. So to put in our data values, we hit stat and then edit. So we plug in all the data values. So Okay, so once you plug in all your data values, you have to sort them in ascending order, because if you don't, it's gonna mess up your 5-number summary, so it's just something you should always do, just in case. So once you click on sort A, you do second, and then put in L1, and click enter. Okay, so once you do that, you click stat, then you head to to calc, and then click on the first one. So list one, and there's no frequency list, so we leave that blank, and then we hit calculate. So it tells you that the mean is 51, so, and the standard deviation is 10.6. So okay, so that's it for that problem. Okay. So C is asking, is it appropriate to use the mean and standard deviation to summarize these data? So the answer is yes, because since the histogram we drew is symmetric, which is typically used to describe the mean, then we could say that it's appropriate. Okay, and D is saying to describe the association of plant heights. So when we talk about this, we always have to mention the center, the outliers, gaps, or gaps. Shape, and the spread. So for the center, as you can tell by the graph, it was pretty symmetric, so, and it didn't have any outliers, so we could say that the data is roughly symmetric. With no outliers. Idiot. And then to talk about the center, we calculated that the mean, oh, I took it off, but the mean was 51 and the standard deviation is 10.6, so we could talk about that. So, the average. Plant height is 61. So far we've covered the shape, which we talked about it being symmetric, the center, no outliers, so we just have to talk about the spread, and if you subtract the minimum from the maximum, so it's going to be 32 from 75, you get 43, so we could say that the range of the plant height is 43 centimeters. need to talk about the gap, because when we drew the histogram, there was a gap between 70 and 75, so you could say that. There was a small gap from 70 to 75 centimeters.
Free throw shooting event, and the highest number of shots made was 32. The next day, a student who had just transferred into the school completed the event, making 35 shots. So now we have a new maximum. So the maximum went from 32 to 35. Indicate whether adding the new student score to the rest of the data made each of these summary statistics increase, decrease, or stay about the same. So we're talking about the mean. Since we're adding a new maximum, it's going to pull everything to the right. So our mean is actually going to get pulled to the right. So this is going to increase. The median, since it's in the middle of our data, is not going to change that much. So that the wording that they use is stay about the same. And the median will stay about the same because it's in the middle of the data and we're changing the maximum values. So the median is going to stay, S-T-A-Y, the same. The range, though, is impacted by the maximum, and since we changed the maximum from 32 to 35, the range is going to get larger, so this is going to increase also. The interquartile range, again, just like the median, is in the middle of our data, right? Here's the IQR. What did we change? We changed something out here, so the interquartile range is not going to change very much. So again, the wording is stay about the same, and that's what this will do. It will stay about the same. Because again, it's in the middle of the data. The standard deviation is a measure of the spread. It's more spread out now, so our standard deviation is going to increase. Why is it more spread out? Because our maximum went from 32 to 35, so this is also going to